Day 2 of y equals mx plus b. This is what the problems were like in the do section yesterday. They just gave you an equation and they asked you two things. What was the slope and what was the y-intercept? Well, another way to represent slope is the letter m. So really they wanted to know what was m, and another way to represent the y-intercept is the letter b, so they wanted to know what was b. What was m and b, and that's your equation, y equals mx plus b. M, the slope, is always right next to x. B is the constant. It's always the number that's by itself. It's not going to change if you ride 3 rides or if you ride 4 rides. It doesn't matter. B is the cost of admission. That's not changing. X is how many rides you ride, so M is how much it costs to ride a ride. So this right here, this value is going to change depending on how many rides you ride. If it's $2 per ride and you ride 5 rides, you spent $10 here plus the $6 to get in. If you only ride 2 rides, you only spent $4 on rides, 2 times 2, plus the $6 to get in. Okay, so those problems, I think you guys are making them a little more confusing than what they needed to be yesterday in the do section. They gave you the equation. They just wanted you to say the number that's by x is the slope and the number that's by itself is the y-intercept. Now, I am going to use the story of the carnival again to try and explain this again because I felt like it was an epic fail yesterday. So in this case, it's $6 to get into the carnival, and it's $2 per ride. X represents how many times. Well, I don't think it's rides. I think it was games I was using. It doesn't really matter. Could be hot dogs. How many hot dogs you buy. But regardless, we'll just say X is games, and it's $2 per game, and it's $6 to get in. So this equation would represent how much money you spent that night. All you'd have to do is plug in the amount of games you played, and you could figure it out. If you played 5 games, that's $10 on games, 2 times 5, plus the 6 to get in, you spent $16. All right, what if the carnival, well, let me start with this. You've probably heard me say a bunch of times already that slope, which I'm going to represent as m, is rise over run. Well, how is that a rise over run? It's only one number. There is no fraction there. Well, you can always make a whole number into a fraction by putting it over 1. But now, how does that fit into the story? What does the 1 represent? The 1 represents games, $2 per one game. All right, it's $2 per one game multiplied by how many games you play. All right, so if you play 5 games, it's 2 over 1 times 5. And when you multiply a fraction times a whole number, you just multiply straight across. Remember that whole number is the same thing as over 1. So it's 10 over 1, which is the same thing as 10. You still get, if you play 5 games, you're spending $10, regardless of whether you write it as 2 over 1 or just 2. But the 1 represents per game. So $2 per one game. So most of the time in these equations, your slope is not going to be a whole number. It's going to be a fraction. So let's say the carnival offers a deal. A lot of carnivals I've been to, you don't just walk up to the game and hand them cash. You got to go to a separate booth and buy tickets, and then you hand tickets to the individual games. So let's say you go to the ticket booth and they're saying 3 games, 3 tickets for $5. That's a deal because normally it would cost you $6 for 3 games, but they're giving you a deal, $5 and you get 3 games. So how would you represent that? It would be like this: y is equal to 5 over 3x. This is saying $5 for every 3 games, as opposed to this, which was $2 for every 1 game. This is a better deal, $5 for every 3 games. Makes the math a little bit more difficult. Let's say you played 6 games. All right, so let's say x is equal to 6 in this one. How much money did you spend? Well, you'd have to plug a 6 in for x. You'd say y is equal to 5 over 3 times 6 plus 6. And 5/3 times 6 is $10. Right? It's just like I showed you before with multiplying fractions on a whole number. It's 5 over 3 times 6 over 1, which is equal to 30 over 3, and multiply straight across. 30 over 3 is the same as 10. So it makes sense. If you played 6 games, that means you bought 6 tickets. $5 for 3 and another $5 for another 3. $5 for 3. You bought 2 sets of them. You bought 6. You spent $10. Right? So don't be confused when you start seeing fractions as slopes. It's just rise over run. It's just money per games. In this case, it's $5 per 3 games. They're lumping it together. They're not breaking it down into how much do I owe you per 1 ticket. It's how much do I owe you for 3 tickets. So that's what happens when slope is a fraction, which is in your very near future. So yesterday was supposed to be simple. I'm sorry that it wasn't. I probably tried to explain too much in one video. When really, yesterday, you really just needed to know how to recognize in this equation which one of these two numbers is the slope and which one is the y-intercept. So the one that's by itself is the y-intercept. The one that's next to the x is the slope. Okay, now we're going to start getting into more of matching up graphs to equations. So you can have, when it comes to slope and y-intercept, I've just been giving you positive numbers, but they could be negative numbers. So if slope, let's say this is a -2, that means I'm gonna have to change the story because they're not gonna pay you $2 to play games. So forget about the story with the carnival and the games for now. The slope represents if your line is going up or if it's going down. Right? So if you have an XY table here, XY graph, and your line is going up like this, that means slope is positive. That's a positive slope. M is a positive number. If you have a graph that looks like this and the line is going down from left to right, that means your slope is a negative number. So when you start getting these types of problems that are multiple choice and it says which equation goes with which graph, you really want to eliminate wrong answers on your multiple choice. So you might look at this and say -2x plus 6 means nothing to me. I don't know what that graph is supposed to look like. Well, at least remember your positives and negatives. If your slope is negative, your line needs to be going down. So if these are your two choices and you recognize that that slope is a negative number, you can eliminate this choice right here because that line is going up. That's a positive slope. All right, you can also eliminate potential graphs with the y-intercept. Both of these lines are crossing up here above 0. This is your origin. This is 0. These are negative numbers down here. These are positive numbers up here. This is +5, that's 6. This is negative numbers down here. So if your line crosses, whether your line's going down or up, if it crosses your y-axis above 0, then that number has to be positive. So let me give you a choice C here. So now you can still eliminate this one because this line's going up and we have a negative slope. So it's definitely not that one. But both these lines are going down. So it could be either one of those because they're both negative slopes. So we've got it narrowed down to two choices. So now you can look at your y-intercept. This is a positive number. That means you're crossing the y-axis above 0. This one crosses it above 0. This one crosses it down here below the x-axis, below 0. So it's not that one. It's this one. All right. If you need to graph these specifically, then you got to start counting. You got to say, all right, this is going to cross at 6. Let's put a dot up at 6. 1, 2, 3, 4, 5, 6. That's my starting point. That's my y-intercept. Remember, we're going to graph this, so this is going to become a line. To make a line, all you got to do is connect 2 points. If I said, here's 2 points, there's a line that connects those 2 points. I'm done. All right, so you need 2 points to make a line. And that's what a graph is of this, is a line. So we need 2 points. The first one is your y-intercept. That's your starting point. Where on this y-axis am I going to put a point? You're going to put it wherever that number is. If it's a positive number, you're counting up that many spaces. If it's a negative number, you're counting down that many spaces and putting a point. Now you got to put the second point somewhere in relation to that point, meaning you got to start from here and count down and over, up and over. Well, it's dictated by the slope. The slope is -2 over 1. That means our line is going to be going down in this direction. So we want our next point to be down here somewhere because it's negative. So you want to count down to, not up to. Rise means up and down. Just because it says rise doesn't mean that it's necessarily going up. It could be going down. Rise just means up and down. Run means across. Okay, so from here, you would want to count down 2 spaces, 1, 2, and run over 1. So your next point would be right there, down 2 over 1. You can connect those, and that would be the line, the graph that goes with this equation. -2x plus 6 would look like this. Those are your 2 points. You connect them with a line. You're done. So this is what you're going to have to do today. Some of it is going to be just multiple choice, which equation goes with which graph, and then you can eliminate choices. So let me give you one more example like that. Let's just say you have y equals mx minus b, right? The reason I didn't give you numbers is because I want you to focus on the positive and the negative to eliminate choices. So let's say you have a choice A that looks like this. Could that possibly match this? The answer is an emphatic no. Because look at your m. Your m is positive. M is positive. That means your line's going up. B is negative. B is negative. That means it's crossing somewhere down here below the x-axis. Well, we got that part right. It crosses the y-axis in negative territory, so that satisfied the B. But our line is going down. We have a positive slope. Our line needs to be going up, so it cannot be that graph. All right, the graph would, for this equation, no matter what those numbers are, the graph is going to have to be a line that's going up, and it's going to have to be crossing the y-axis somewhere down here. So like that would work. This could potentially match that because your slope is positive, it's going up, and it's crossing the y-axis, the y-intercept at a negative number down here somewhere. So this could match that. This could not. All right, I think there's 3 problems where you actually have to draw a graph. So some of your problems are going to look like this. Just match the equation to the graph. And the other ones are going to be create your own graph. So if you have to create your own graph, let me say that it's this. Y equals 2/3 x plus 1. How would you draw that graph? Well, you need 2 points. Start with the y-intercept. That's your starting point. So you draw your little graph. The y-intercept is a positive 1, so we're going to go up because it's positive, 1 space. There's 1 point. We're halfway done. See how easy that was? Halfway done. All you need are 2 points. That's one of them. All right, from there, we need another point. We're going to use the rise over run to find that second point. We're going to count up and over from our starting point. All right, this is a positive slope, so we know that our line needs to be going up. So our second point should be up in here somewhere, so that it'd be going up. So that means we got to go up and over. How far? Rise over run. Up 2 over 3. So you go up 2 spaces over 3. That's 1, 2, and 1, 2, 3. That is right here. So that's what the graph would look like. Here's the biggest mistake that I see in these type of problems. People get the first point right. They're like, okay, that's my starting point, the number that's by itself. That's at 1. Good, you're on the right track. Most people get that part right. And then when they go to find the second point, they start counting from the origin again. You're so used to counting starting from the origin when you plot points that it's just a habit that you start from here and you go up 2 spaces and you only end up right there, then you say your point's over here when really your point is right there because you're supposed to start from the starting point. How rise over run takes you from one point to the next point on the line. The line's not even going to go through the origin. The line's going to look like this. There's not even a point on the origin. So you would never use the origin to count from one point to the next. So avoid that mistake. When you go to find your second point, make sure you start counting up from this point. That's why I call it the starting point. You're starting from here to count up that many spaces. Unless it's negative, then you start from here to count down that many spaces. Okay, so you got a few problems like that where you just got to draw a quick little graph like I'm doing. And then you got some problems where you have to match up a graph to an equation. And I'm giving you 4 of those problems right now, and I'm not listing them on the do section. This is the first time I think I'm doing this to you guys. I've already done this to geometry. And it's so that I know if you're watching the whole video, especially a long 16-minute one like this. So I'm checking Tuesday's do assignment to make sure that it includes these 4 problems, which you can't totally see all of them, it doesn't look like. This could be a problem. There we go. All right. You've got 4 problems here. Problem 1 is mx plus b. Which one of these, A, B, C, or D, could potentially be the answer to that one? There's only one right answer for each one. You're not going to use A twice. You're going to use A, B, and C, and D once each. All right. Which one has a positive slope and crosses at a negative? Which one has a negative slope and crosses at a positive y-intercept? Which one has a negative slope and crosses at a negative y-intercept? So you got to match up. All 4 of these graphs are different. All 4 of these equations are different. So tell me one is B or one is D or whatever. You don't have to copy down all the graphs. I just want to see for your answers for these 3 problems, 1 is D or 2 is C or whatever. Just give me 4 numbers with a letter next to it. And that'll suffice as doing these 4 problems. And you can hit pause here if you need to and come back and stare at the screen and do these. But make sure you're typing in 4 more answers for this. Don't just give me the problems that are listed on the do page, because if you do, I'm going to know that you didn't watch this video.